All right, let's get right into it. We're in this time where the most powerful AI models, they're kind of like supercars. Amazing, but totally out of reach, locked away in these high-tech garages. But what if you could get most of that horsepower in a car you could actually park in your own driveway? Well, that's exactly what we're talking about today. A breakthrough that's putting massive AI power right onto your home PC.
For most of us, the answer to that has been a big, fat yes. And it's frustrating, right? These top-tier models like the Qwen 3.5 family, they are absolutely brilliant. But trying to run them locally? Forget about it. You need some serious hardware, the kind of pro-level GPUs that are just way beyond the budget for the average person. It's a huge wall.
And this number right here, this is the wall. To run the full-fat, uncompressed version of the Qwen 3.5 model, you need a graphics card with around 18 gigabytes of VRAM. That is a ton of memory, and it pretty much puts this incredible tool out of reach for a whole lot of people. So, how do you get around that?
Well, the answer comes down to this really clever technique called quantization. You've probably heard the word thrown around. At its core, it's basically a super smart form of compression. It's the key that lets us shrink these absolute monster models down without, totally scrambling their brains.
So what's actually going on here? Well, the original model stores all of its billions of parameters, its weights, as a 16-bit number. That's a lot of detail. Quantization's job is to squish those weights down into a much, much smaller format. In this case, just 4 bits. It's kind of like taking a giant, super high-res photo and saving it as a much more efficient file.
And the difference here is just, wow. You're going from 16-bit precision all the way down to 4-bit. That's a 4 times compression. And just look at what that does to the memory requirement. It plummets from a whopping 18 gigabytes of VRAM down to a way more manageable 5 gigabytes. All of a sudden, this incredibly powerful AI can actually run on a ton of different consumer-grade computers.
But okay, here's the catch. Not all compression is the same, right? If you just crudely shrink something, you lose a ton of quality. And that's where Intel's method, called AutoRound, comes into play. It has a kind of secret sauce that helps it hold on to a shocking amount of the model's original smarts.
So the simple way to do this would be to just round every number to the nearest 4-bit value. But that's like taking a sledgehammer to a delicate sculpture. You're going to break things. AutoRound is way more like a surgeon. It looks at all the complex relationships between the weights and then figures out the absolute best rounding decision for each one, the one that will have the least negative impact on the whole model. It's just a much, much smarter way to do it.
The way it pulls this off is pretty brilliant. Just think of it like a zip file. The model's weights are stored on your GPU in that super compressed 4-bit format, which saves a ton of space. But, and this is the genius part, when the model actually has to do the math, it temporarily unzips those weights back to a higher precision. So you get the best of both worlds, tiny storage footprint, but high-quality thinking.
And that really is the whole point, isn't it? That's the promise of technology like AutoRound. You get the core intelligence of a massive model, but in a package that needs just a tiny fraction of the resources. It's a total game changer for making AI accessible to everybody.
Okay, so that all sounds great on paper, right? But how does this tiny giant actually perform in the real world? We're going to move on to the tests now and see how this compressed 4-bit model actually holds up when you throw a bunch of complex tasks at it.
So first up, a really tough coding challenge. The model was given a pretty complex code base and asked to figure out how changing one little thing would ripple through the whole system and break other files. I mean, this is a developer's nightmare. And the result? It was a huge success. It totally nailed it. It correctly found which files would break, and then it generated high-quality code to fix them. Really, really impressive.
Next, we threw it a creative curveball. Build a whole animated financial dashboard from scratch. And this is where we start to see the trade-offs. It managed to create a basic, functional web page, which is cool, but it really struggled with the fancier stuff, like smooth animations and telling a dynamic story with the data. The core logic was there, but some of that creative spark, it definitely got lost in the compression.
And finally, a deceptively simple little language puzzle. Just write 10 sentences that all end with the word happy. Should be easy, right? Well, you could almost see the quantized model thinking. It made a bunch of drafts, it kept trying, but it still couldn't consistently follow that one simple rule. This really shows that when you need precise, strict logic, that compression can sometimes cause it to trip up. So after running it through the gauntlet, what's the final verdict? Well, it's pretty clear that this kind of tech comes with some very specific pros and cons. Let's break down the big takeaways. If you look at the final scorecard here, a really clear picture starts to form. The biggest win, by far, is accessibility. This just opens the door for so many more developers and hobbyists. And for logical stuff like coding, its performance is genuinely great. But on the flip side, when you get to the subtleties of creativity or following really strict rules, that's where the compression shows its limits. So no, it's not a perfect one-to-one replacement for the full model. It's a powerful tool, but with its own unique set of skills.
And look, this is probably the most important thing to get. The goal here isn't to make a perfect, tiny clone of a giant AI. It's about bringing, say, 90% of the power to 90% more people. It's a massive shift from AI being a resource for just a handful of people with supercomputers to being a tool that pretty much anyone can run and experiment with on their own machine.
Which leaves us with this one last big thought. As these smarter compression techniques like AutoRound just keep getting better and better, you have to wonder, is this the path forward? Is this kind of intelligent, smart compression the key that finally unlocks the door to having a powerful AI in everyone's hands on every single device? It's definitely something to think about.